In this video, we're going to continue looking at the wave function and answering questions from exercise 9.2 of your higher textbook. So we're expressing some expressions, sine x minus cos x. So we're expressing that in the form k cos x minus alpha. So it specifically says that which form we want it in, which is just helpful because you could write it in any form in theory. So this expression is a mix of sine and cos. There's nothing else we can do to it. We can't manipulate it in any other way. So we're going to express it just in terms of k cos x minus alpha. Now, using your higher formula sheet, you know that you can write cos of x minus alpha expanded out. So just being careful with your formula sheet. Remember that there's a k in front. So we've got k, and we've got cos x, cos alpha, and we've got, if it's a takeaway, it's going to be a plus, and don't forget your k again, sine x, sine alpha. So you've expanded that out just using your formula sheet. Okay, now we've got two expressions here, and we want to equate things that match. So looking initially, we've got sine x here. Now if you look over, sine x is over here. So this means everything in that term, so in this case, if you look at your right hand side here, you've got k sine alpha is going to be equal to 1. 1's the only thing that sits near that sine x. So k sine alpha equals 1. It's the same as if we're going to make these expressions the same. Then, if we're looking at our cos terms, we've got cos x here and we've got cos x here. And looking at what's around these, we've got k cos alpha, and that's going to be equal to, and around here we've got a minus, so it's a minus 1. So always just being careful of your signs here. Once you've done that bit, you're back to where you were before, and we are just going to solve sort of these simultaneous equations and write it in a different format. So we're going to square everything. K squared, sine squared alpha, 1 squared is 1. K squared, cos squared alpha equals 1 minus 1 squared, positive 1. We are going to add these two. And you will have k squared sine squared alpha plus k squared cos squared alpha, 1 plus 1 equals 2. Take out your common factor of k squared, sine squared alpha plus cos squared alpha in your bracket equals 2. We know that sine squared alpha plus cos squared alpha from your Nat 5 identities equals 1. So k squared equals 2. We know that k is going to be plus or minus the square root of 2, and k is positive as we're told that in the question. So k is going to equal the square root of 2 as k is greater than 0. We were told that in our question there. So we are then going to go down here and look at these two equations subbing in k now. So 1, let's give myself more room. Now 1 was root 2 sine alpha equals 1. We know that sine alpha equals 1 over root 2, and your acute angle there, it's an exact value. What angle gives you 1 over root 2 is sine? 45 degrees. If we draw a little sketch, that will give us, there's our sine graph, it's a positive 1 over root 2, so it's going to give you 45 in here, 45 in here. So those will be our two possible answers. Don't need to go further than that yet. Then our second equation, we've got root 2 cos alpha equals, sorry, it was minus 1. Cos alpha, give myself more room again. Cos alpha equals minus 1 over root 2. Your related acute angle, dropping that negative, is going to be 45 degrees as well for your cos. drawing your cos graph. Again, just needs to be a sketch. And it's your negative, so it's actually this answer here and this answer here because it's your minus 1 over root 2. So it's going to be 45 degrees less 45 degrees. Sorry, I've done that really stupidly. Let's draw this better. If I put in my 180 there, you've got 45 less than 180 and 45 more than 180. Your symmetry around your 180 mark. The one that matches here, 45 less than 180, 45 less than 180, 180 minus 45 equals 135 degrees. So if we write that out nice and clearly, we've got k equals our root 2. We've got our alpha equals 135 degrees. So writing out our original expression, sine x minus cos x equals root 2 cos x minus 135 degrees. And that's you done.